Today we're going to learn about the commutative property. Commute. I want you to remember this right here. What I'm going to give you is commute. What does it mean to commute? This word comes from commute, which means to move. So with the commutative property associated with the word move, and maybe that'll help you out. Our learning target today is to identify and apply the commutative property of addition and multiplication. So there's actually two commutative properties, one for addition, one for multiplication. Very similar, except for the fact that those two operations are different in their nature. Make sure this is page number 10 in your notebooks, please. And for those non-note takers, this is definitely one of those lessons that you want in your notebook. All property lessons, very important to have as they're so fundamental to math. So properties. Properties are mathematical laws that every number system obeys. So the commutative property is one of the mathematical laws that our real number system employs. And these properties are derived by logic, but they're very intuitive to us. They're very simple. They're common sense. It seems like it's common sense. So sometimes they're very easy to get confused. Two main vocabulary terms I'm going to use throughout this video and subsequent videos. The first is algebraic term. So you probably know what a term is, but we're going to define it. So a term is either a single number, so I'm going to give you an example. So 5 is a term, or a variable, so y could be a term, or a combination of factors. And what that means is maybe 3xy. So these are a combination of factors here. And terms are separated by addition and subtraction. So we had addition here and we have subtraction. So I know that this expression has three terms because we can separate the terms out by addition and subtraction. We've got one term right here, we've got one term right here, and we've got one term right here, and this is the only negative term. This subtraction sign actually goes with that term, so it's a negative term. So we have three terms, right? And if we added another addition sign and a number, right, then we would have four terms. So addition and subtraction separate terms. And then algebraic factors, these are numbers or variables that are being multiplied. So let's take negative 3x for example. This is an example of a algebraic factor. We've got negative 3x, y, and then let's say, plus 5b. So in this example right here, what we have is we've got two terms. We've got two terms because we've got one addition sign. And then within the first term, what we have is we have three factors. We have three things that are being multiplied. We've got negative 3 is being multiplied, x is being multiplied, and y is being multiplied. And then in this second term, we only have two factors. We've got 5 is being multiplied, and b is being multiplied. So two terms, and then 5 factors, 3 in the first term, 2 in the second term. That's essentially how these two vocabulary words work. Alright, so showtime for the commutative property of addition. Let's go ahead and formally define this bad boy. So CPA is a way that you can code the commutative property of addition in Schoology. And this states that changing the order in which terms, there's that vocabulary word, are added does not change the sum. So changing the order that terms are added does not change the sum. And another way of thinking about this word sum is the outcome. Changing the order things are added or terms are added does not change the outcome. So the math definition for commutative property is a plus b. If we add a to b, it's the exact same thing. It's equal to adding b to a. And we can go ahead and test this out with any numbers that we want. So let's go ahead and choose simple numbers just so that we can kind of get a better understanding what this property even is. So if we have 5 plus 3, what this property is saying is the same thing as adding 3 plus 5. We can add the 3 to the 5 and it give us the same exact value as adding the 5 to the 3. So this simplifies to an 8 and this also simplifies to an 8. So you can see here the commutative property just changes the order that things are added. And then an example of variables. Let's get an example of variables. So if we had 5xy plus 2b plus 4, right? We could go ahead and say that this is the exact same thing. We can change the order of these terms. So think about it. I want you to think about it for a second. We've got three terms here. We've got one term, we've got two terms, and we've got 3 terms, and they're all positive, so we can go ahead and just say, this is the same exact thing as just saying 2b plus 4 plus 5x. Why? They're all the same. 2b is still a 2b, 4 is still a 4, 5x is still 5x, y, sorry, and they're still being added. So we haven't changed anything as far as the operations. We've just commuted the terms, right? And we can do this pretty much with any example. So the question now becomes, what about commuting subtraction? So what if we had maybe 5 minus 3? And to that I would respond, commuting subtraction is pretty much just turning that subtraction back into addition. So if we turn the subtraction back into addition, what we have is 5 plus a negative. Remember, subtraction is the same thing as plus a negative. So we can commute this back in, or convert this back into addition. And now that it's back into addition, we can go ahead and we can commute the negative 3, and we can commute the positive 5. As long as I don't change the signs, I should be okay. So we can say this is the same thing as negative 3 plus 5. The 5 is still positive, and the 3 is still negative 3. So we haven't changed the value of anything, and this is still going to equal positive 2, right? 5 minus 2 is 2. Negative 3 plus 5 is also 2. So it's all the same, right? And the same is true when we have variables. So if we had negative 2x, right, plus 2, this is the same thing as saying 2. We can take this plus a 2, and we can commute it in front of the negative 2x. We can just say minus 2x, right? Or plus a negative 2x is the same thing as 2 minus 2x. The commutative property of multiplication. So very similar to the property of addition, except CPM, and that's how you can code it in Schoology, states that changing the order in which factors are multiplied does not change the outcome. There's that word factors or product. Okay, and the math definition for this is A times B is the exact same thing as multiplying B first and then A. And you can see this done with numbers. If we let's take arbitrary numbers, so let's just take 10 times 7, right, is the same exact thing as if we multiplied 7 times a 10. These both are 70. So it doesn't matter what order we multiply them in. Or an even better example is, if we had negative 2x, this is the same exact thing as saying, let's take this factor right here, this factor negative 2, and commute it behind the factor of x, and rewrite it as x times a negative 2. So these are the exact same things. We're commuting factors now. With addition, we're commuting terms, things that are being added or subtracted, and now with multiplication, we're commuting our factors. So an even more complicated example is if we had 5zba, we can say that this is the same thing as saying z times 5 times b times a. The 4 factors are still being multiplied. We're just changing the order in which they're multiplied. So the question now becomes, what about division? And it's very similar to subtraction. With division, we have to convert it to multiplication. So if we had 5 divided by 5, okay, times 3, we know that 5 divided by 5 is 1, and we know that 1 times 3 is 3. So we know that this simplifies to 3. But if we wanted to rearrange this, what we could say is 5 times, and since this 5 right here is being divided, we're going to put a 1 in the numerator and a 5 in the denominator. So 5 times 1/5 times 3. And now that we have that division as multiplication, we can go ahead and commute it and say 1/5 times 3 times 5 is the same thing as 5 divided by 5 divided by 5 times 3. And if you don't believe me, go ahead and put each of these into the calculator and see if they come back as the same value. Alright, so we're going to get into a couple examples right away. And I've got some notes on these examples. So go ahead and pause the video and copy down the note if you want. So we're going to provide justification for each expression. This is called a proof. So you can see with this proof, we're given this expression, because it tells us that we're given this expression, negative 5x plus 4 minus 3y. And we have to figure out how come we can go from this expression to this expression. What allows us to rearrange or rewrite this expression? So I want you to pay attention to the order right now, because the commutative property is the order. And we have to figure out what changed in the order. Did we change things that were being multiplied, or did we change things that were being added? So negative 5x plus 4 minus 3. We've got three terms here, separated by these signs, right? And here we also have three terms. And I want you to pay attention to the order of the terms. We've got a negative 5x, that did not change. And then all of a sudden we have a 4 and a negative 3y. So it looks like this negative 3 and this 4, they got commuted. They commuted the 4, the positive 4, and the negative 3. And because they commuted the terms, we can say, okay, this is the commutative property of addition. Now look at this next example. We start off with negative 5 plus 3 times x minus 3. So how many terms do we have here right now? And you're probably thinking, we've got 3 terms, Mr. Shalongo. And I would tell you, no, we don't have 3 terms. In fact, we only have 2. Because remember, a term is a number, a variable, or a combination of factors. So things that are being multiplied. And because this 3 is being multiplied with this parentheses, it's actually just considered this one term. So what happened? Did we change the way we are multiplying, the order we are multiplying, or adding? So you can see if we have our 2 terms here, then we have got our 2 terms here. And the order of addition is what changed, because they've taken this 3 times x minus 2, this term right here, and they've commuted it in front of this negative 5. And now we've got 3 times x minus 2 minus 5. So we can go ahead and say that this is the commutative property of addition. And now we've got to figure out, well, what did they do from the second expression to the third expression? Well, it looks like the terms, the order of the main terms did not change, because you can see here we've got 3, 3, and then we've got the negative 5 still in the same position. But if you look closely, the terms inside the parentheses, so now we're looking at the terms inside the parentheses, the order that they changed, the order they were being added or subtracted changed. We had x minus 2, and now we've got this negative 2 plus x. So they took this negative 2 and they commuted it in front of the x. So we can say that this is also the commutative property of addition. Okay, so then we're going to do the same exact thing. We're going to figure out what changed. So now we should kind of be familiar with these proofs. So we've got 5y minus 3y squared plus 2. And here we have 5y minus y squared times 3 plus 2. So you can see that the order that the terms are in is roughly the same, except this middle term seems to have changed a bit, but the position of the terms is the same. So probably not addition. We did not commute anything that was being added. So let's look more closely at this particular term. We've got this negative 3 that's being multiplied, and we've got this y squared that's being multiplied. And now we have this negative y squared that's being multiplied, and this 3 that's being multiplied after it. So we've changed the order that they're being multiplied. So we can go ahead and say this is the commutative property of multiplication. This next example, we've got 3 minus 4 times x plus 1. So we've got one term, we've got 2 terms, right? And here we've got one term, and we've got 2 terms, because remember, these are being multiplied, so they're considered factors. They're considered just one term. You can see that the order seems to be about the same, except now this 4 is not being multiplied first. This x plus 1 is being multiplied. So this factor right here was commuted in front of this factor right here, this negative 4. So we can also say this is the commutative property of multiplication. So these are the first 2 examples that you'll see at the problem set. Look for the second video to see the other styles of questions that you'll see on the problem set. The second video will probably only be about about 4 minutes, maybe 5 minutes. Maybe it'll only be 90 seconds. Tune in to find out.